Herzlich willkommen, meine lieben Teilnehmerinnen und Teilnehmer. Bevor wir gleich offiziell loslegen, noch ein Hinweis zur Sprache. Die gesamte Veranstaltung wird gleich auf Englisch abgehalten werden. Dann wählen Sie bitte einfach den jeweiligen Sprachkanal, den Sie lieber haben möchten. Entweder einfach Englisch oder halt die deutsche Übersetzung. Sie können das einfach unten bei Zoom, haben Sie den Button Dolmetschen, da können Sie die Sprache auswählen. To all of those who want to follow this event in English, please select the English speaking channel, or if you want to follow in German, choose German. You will find this on the bottom, at the bottom of your screen of Zoom, where you can select your languages. Yeah, that leads me to the official welcome. Ladies and gentlemen, welcome to the second event within the talk series Impetus for CDR, which is provided by the Federal Ministry of Justice and Consumer Protection CDR initiative. As you might know, on a monthly basis, this event series wants to shed light on the different facets of a responsible digitalization process. By inviting experts from businesses, academia, civil society, we want to discuss how companies can take responsibilities in their digital transformation seriously. And today, we want to talk about data anonymization. The choice of this topic is no coincidence, quite to the contrary. As you might know, one of the cornerstones of the CDR initiatives is the CDR Codex. And if you read the Codex, you will realize that personal data plays a big role in this Codex. And if you read through the chapter on personal data, you will find some statements such as the importance to promote responsibility technology design in dealing with personal data, for example, by means of applying privacy by design principles and data pseudonymization and anonymization is written in this codex. So while these terms might sound very, very technical, in reality, they are very practical. They have real implications on what companies and what other criminals can be doing with such data. And also, many companies have yet realized that anonymization is not only for the freaks, but is something that might sell. So, for example, I think it was Apple as a major international recognized brand that in 2017 explained that it would apply the concept of differential privacy in its products and service development. And since then, more and more companies have realized that personal data is not only of great value, the oil of the digital economy, but also a great liability. So I'm delighted that in this event, the CDR initiative has been able to win over Professor Dr. Paul Francis for a presentation on simple GDPR-strength anonymization. Professor Francis is scientific director at the Max-Planck-Institute for Software Systems and a leading expert in the field of anonymization. He's also, if one might say so, a serial founder. And Paul, I really want to understand how this is possible. A simple GDPR-strength anonymization, it seems like many contradictions here. GDPR, anonymization, can this be simple? So, but before we start with your presentation, just a few words about how we proceed. So Paul will give a presentation about his ideas and his tool that he developed. After these presentations, we will have time for your questions and comments. So please use the comment function when you want to utter your voice. You can use it in German or English, it doesn't matter. We have the interpreters here with us, so write it in whatever language it suits you best. Also, please note that this event is recorded. I will not state your names when I read out your comments, so your anonymity will be secured in this event. And my name is Christian Thoren. I'm the director of the Institute of Consumer Policy, and I'm delighted to be with you throughout this session. So Paul, now we are interested to learn more about what you mean by simple GDPR-strength anonymization and how simplicity in all this is possible.
Okay, you can hear me. Let me share my screen.
We can hear you, so everything is perfect. Also,
can you see my screen?
Yes.
Okay. Thank you very much for the kind introduction, and I'm very happy to see so many people have joined in. I apologize in advance for speaking in English. You would think after 12 or 13 years in Germany I could do better, but well, maybe my excuse is I'm an American, and you know how Americans are about foreign languages. Anyway, yeah, simple GDPR strength anonymization. I have to confess, I don't know my audience. It's always nice to know who's listening and why and so on. And I don't have a good sense of who the audience is and what you know, how technical you are, what you're interested in, and so on. So I try to keep things as simple as I can, and hopefully it's informative. And if it's not, then we'll have some question and answer period later on, and we can explore what you wish. So as the introduction said, I'm primarily a director at the Max-Planck-Institute for Software Systems here in Kaiserslautern, and I think you mostly know what that is, so I don't have to say. And I've been researching the problem of data anonymity for almost 10 years now, and in fact, I would call it practical data anonymization versus a lot of what my academic colleagues do, which is more theoretical and less practical. And as part of trying to make practical solutions, I've done this research in the context of a research partnership with the company Aircloak GmbH. So we work closely together, and this helps me engage with real users and understand what the real problems are in data anonymization, especially in the corporate world. More recently, I've founded an open source, not quite pure open source, but open source project using similar technology that we had at Aircloak. And this will be primarily the topic of my conversation. So, there's lots and lots and lots of aspects of data privacy and data protection and so on. I focus on a very narrow, part of all of that, which is data anonymization. And specifically, this notion that you would like to learn statistics about personal data or release statistics about personal data, but without learning or releasing any information about the individuals in that data. So in a way, it sounds quite simple. I'd like to know that 20 people are in the database that have cancer and smoke a certain amount, but I don't want to know that one of them has the name of Paul Francis, whatever. But of course, this has to be done in such a way that the remaining statistics provide useful information. And this, of course, is one of the things that's always been hard about data anonymization, is that it's easy to protect it, but the resulting statistics that you can get out of the data may not be so useful anymore. And this is really the hard part of the problem. Now, as I'm sure most of you know, the GDPR has a definition for data anonymization. The subsequent restrictions or lack of restrictions on what you can do with it. So GDPR defines anonymization as a situation where the personal data is no longer personal. So you've done whatever mechanisms that you need to do on the personal data so that it's no longer personal. And once it's no longer personal, then GDPR no longer applies. You don't have to worry about right to throw it away, or how to store it, or how to release it, or anything else. It's no longer personal data. It can go anywhere at once, and you don't have the responsibility for that anymore. Now, the bar for what constitutes anonymity in GDPR is quite high, but it's not 100% risk-free. I think to a small extent people disagree on that, but if I look carefully at what, for instance, the French Data Protection Authority, CNIL, has said, or in the UK, they don't say it has to be absolutely 100% risk-free. Generally, they say, it should be anonymous by reasonable means, reasonable attacks on the data, or reasonable background knowledge about the data, but not any possible means. So there is a chance to make anonymized data useful, and still strong enough that reasonable people would agree, yes, this is GDPR compliant, if I can use that word. And I should say as well that the GDPR itself doesn't have really clear criteria on what constitutes anonymity. It's really quite vague. And different data protection authorities may have different standards for that. And I know that different data protection authorities are really working on this as we speak. And so progress will be made in terms of how to certify, for instance, that data is GDPR anonymous. But we're not really quite there yet. Okay, I'm not going to talk too much about the technology, and I don't know how much my audience knows about these things, but at a high level, data anonymization is kind of simple to understand. There's really three mechanisms, for instance, that are commonly used over and over again. And I won't delve into these into too much detail, but they're simple to understand. So one is generalization, and this is where you take more specific data, like say the date of birth of somebody, and you generalize it into a less precise form. For instance, date of birth would go to year of birth. It's a very simple idea, but it's very powerful and very commonly used. Second is the concept of noise, where you take an output like the count of individuals that have whatever certain attributes or something, and you change it a little bit, right? We call that adding noise, but it's really perturbing, kind of a statistical output of the data. So you might have a count in the data that contains 24 individuals, but you might perturb it a little bit to make it more anonymous and say, well, we'll call it 28 individuals. So that's adding noise. And the last is it's suppression. I mean, I call it here low count suppression. But the idea is that if you have data that pertains to too few individuals, not enough people, you simply suppress it. You simply don't report it. So if I had some data and only 2 individuals, for instance, were in that data, in that output bin or something, I might just suppress that data and simply not announce it at all. So these 3 things you see over and over again, and they're fairly simple concepts. And for instance, if you look at k-anonymity, which many of you may know what this is the idea of making sure that every output row in some data looks like k-1 other rows. It's entirely built from generalization and suppression. And if you look at differential privacy, which was mentioned at the beginning, this is primarily about adding noise, but there's some generalization in the process as well. So, at some level, these are the 3 things you have to understand, or you would have to use if you wanted to anonymize data: generalization, noise, and low count suppression. So in a sense, anonymization is not that hard. But of course, in some sense, it's not that easy too. I mean, you need to apply the 3 things I told you typically. It requires some expertise. And if you don't have that expertise, then indeed it is quite hard. But if you have that expertise, it's a relatively straightforward process, but it can also be a very lengthy process. And I try to illustrate that here in this drawing. But typically the hard part of data anonymization is figuring out how much generalization or how much noise or how much suppression you can get away with and still satisfy whatever the use case is that you have. I mean, the use case would mean, you want to release data at a certain granularity. People are going to look at that data to accomplish certain things. And so that data has to have a certain amount of accuracy or a certain amount of precision or something like that. And so really the anonymization process, if you were to do it manually, is one of, trying to find the right balance between different parts of the data. And then maybe there's a design team or something that looks at that and says, well, no, the data quality is too poor in this way and that way. And then you go back and you work some more. And so it's a process you go through to get to the point where the data quality is good enough. But then after all of that, you typically need to get approval, at least from your data protection officer in your company, maybe from a data protection authority in your region or in your state. And they may say, no, I don't think that's anonymous enough, and they may kick it back. And so really you can easily get into a multi-month process to do something that technically is fairly simple. But nevertheless, there's a lot of things that have to get right. And then finally, at the end of all of this, you produce some anonymized data and everything's good. But then somebody may say, well, the use case has changed. We now want, to know what people's locations are. So we need to add that in. And then you kind of go through the whole process again. And again, it can take weeks or months to go through it. So it is a doable, but it's a lengthy process. And of course, companies do it all the time. but it can be a bit painful, and this is what we're trying to address. So it's been almost 10 years now that I've been doing this research at Max Planck and working with Aircloak with a goal of making anonymization easier and faster. In a sense, we want to take this complex process that I showed on the last page, and we want to make it simple and fast. So first of all, no anonymization expertise is required. Rather, you have people that know how to analyze data, but they don't have to know how to anonymize data. We want the data quality of the resulting product to be good enough for most use cases. And our hope was to get a kind of pre-approval from many data protection authorities so that you wouldn't have to go through over and over again the approval process. So the idea was that we build a product that the product gets pre-approved for any use case. And we did have a little success with this, but not enough. The product gets pre-approved for any use case, so you don't have to worry about that anymore. And then it's just a matter of using the tool and getting the data out without anonymization expertise. So this was our dream. And I'm going to talk a little bit about how we went about it, in spite of the fact that ultimately that's not what my talk is about. But I just want to, in the end, we failed actually as a company, and I want to kind of explain why at some point. So what we built, and now we're talking about 4 or 5 years ago, we built a system that is kind of a proxy. It's an SQL being a database language. It's an SQL proxy that sits in front of a backend database. It provides an SQL interface, so an analyst or an application can talk to it using standard SQL. It communicates with the backend database, and we were able to support a number of different backend technologies. And then it provides an anonymized answer. So, you know, the idea is in a sense quite simple, and we wanted to accommodate lots of backend technologies, both SQL and no SQL. We did use all three of sort of the big three anonymization mechanisms that I mentioned before. And this led to, you know, a system with strong anonymization and a system that had data quality, which is actually far better than you can typically get with either k-anonymity or differential privacy. So it had many good aspects. Of course, we wanted our customers to be confident that that this product, the anonymized output of this product, was GDPR compliant, and we worked hard at this, and this was not easy, but there are several basic things that we did to make this happen. One is that the technology was very transparent. It was not proprietary. We published exactly how the system worked. Of course, we did a thorough internal evaluation of anonymity. We strongly encouraged external evaluation of anonymity, not just by publishing the technology, but we actually offered a bounty program for data anonymization. So we ran 2 bounty programs with a total purse of $50,000, inviting people to attack the system and find weaknesses. And we're the only organization that's ever done that, as far as I know. And this was a helpful process, not just in learning about the technology, but in building confidence that it was strong anonymity. And then, of course, we would do the normal things, which is publish vulnerability notifications when attacks were found, and move towards sort of a no known attacks position. So we find attacks, we aggressively find attacks, we fix them and iterate that process. And if you think about it, this is what anybody that offers a security solution of any sort goes through. They build something, they evaluate it, they get external evaluation, vulnerabilities may be found, they publish those vulnerabilities, they fix them and move forward. So it's really a standard, classic approach to data security, but surprisingly, it doesn't happen all that often with data anonymity. So this is generally what we were trying to do. We had some success, both with data protection authorities and with companies using and buying the product, but ultimately, we did not succeed as a startup. And why this is, it's a little bit hard to say, but one thing I would say is that we had quite a high setup overhead. So you had to integrate with your database, and you had to configure the thing, and you had to set up machines. It's not something that somebody could just do, in an hour or two. in one afternoon. It really involved bringing a lot of people together and integrating the system in with your existing system. For various reasons, it could be confusing for analysts. I mean, we had SQL, but there were some unique characteristics to it that sometimes made it hard to use. And we built a system that the analyst, we assumed that the analyst did not have the right to look at the raw data. So the analyst would make a query, get an answer, and often be a little bit unsure about what the quality of that answer was, you know, how much noise was added and so on. And this just made things a little bit harder for people. And finally, we didn't get as many pre-approvals from data protection authorities as we wished. And this was in part because we didn't get as many customers as we wished. If we had more customers, then they would go to their DPAs, we get approval and then, you know, get the ball rolling. But this didn't really happen. So fine, we tried to do this. We were not quite successful. So what's the next step? So AirCloak is all but disappeared. They still run a little bit, but it's kind of a done deal. And what I did, myself and some of the engineers from the project early in the year, is that we switched to an open project, something we call Open Diffics. And we're trying to do several things, but one is we're trying to make the system even more simple to use, to really lower the barrier to using the system in the first place. And secondly, we want to make it free, or at least free for most use cases. So currently it's a project funded by Max Planck as research, but within a couple of years, we certainly hope to spin it off so that it becomes a self-sustaining process. And to those of you listening, you can help with this if you want to get involved. In any event, we're releasing under a business source license. And if you don't know what that means, essentially it means that it's free for most use cases. And in our case, it's free for any commercial internal use case. Our plan is hopefully to charge for use cases where people try to make money off of the software itself. So this would especially mean cloud computing kinds of use cases. And we're building two products. One is a desktop app, and I'm going to demo that right after this slide, I think. And this is meant to be really, really simple to use. Hardly any technical expertise, much less anonymization expertise.
Paul, for us to have more time for the Q&A, so 2 minutes left, okay?
Okay. Thank you. Let me go to the demo then, and I'll try to speed it up a little bit in that case. So thank you for the reminder. So what I'm going to show you is it's a desktop application for Windows and Mac and Linux, and it's very simple to install. You just download the binary and double click, and there you go. And I'm going to just try to quickly walk you through the process that an analyst would do to produce GDPR-strength anonymized data. So first, we load in a CSV file. So I'll take one here. And the first thing you can do is look at the data in the CSV file. So the person using the system is trusted to look at the data. So you have a view of it, and this also already makes it easier to use in the AirCloak product. And you can check and make sure that the import process went all right. There's a little bit of configuration involved. I won't describe that in any detail right now. Basically, you have to pick a column that contains identities of the individuals in the system. And then you get some columns. These are the columns that are in this data. This is taxi data, New York City taxi data. So there's columns like, per trip, how long was the trip? Where was the pickup, latitude and longitude, where was the drop off, how much was paid, when did it happen, and so on. And, let's just say that as an analyst, I'm interested in knowing the correlation between the fare amount and the trip distance, which they should correlate because the longer the trip, the more you would pay. So I picked those things, and down here, what we see is that anonymization has already taken place, right? So the system anonymized that data, And first of all, it's giving me an anonymization summary. So it's giving me some information about the quality of the data. And secondly, it's showing me the anonymized data itself, what the output should look like. And I can look at this data, and under the hood, it's doing some, suppression, and it's doing some noise addition. So it does that on my behalf. I don't have to worry about that. And I can look at this data, and I can look, for instance, at this field here, suppress count. This is telling me really how much of the data has been suppressed. And I can see that 5% roughly of the data has been suppressed. Whether this is okay or not depends on what I'm trying to do, but I can see at a glance that there's been some suppression of data. Moreover, I'm outputting, sort of histograph bins. And a lot of these bins have been suppressed. More than half of the bins have been suppressed. And of the distortion of the data, it's distorted. The median distortion is about 5%, but the maximum distortion is quite high. So I could look at this and I could say, well, that's not quite good enough. And typically then what you need is generalization. So I can take this trip distance, which I guess if I look up here at the raw data, I can see that trip distance is fractional, right? So I might come down and say, okay, I'm going to make trip distance every 5 miles instead of, so this is in miles. I'll say I'm going to put it in bins of 5 miles instead of this high detail. And the fair amount, I'll put it in bins of $1. So I can look at my data again. It's anonymizing now. It should be done soon. There we go. And I can see that there's far less suppression in the data. There's far fewer bins. I don't know, I had 10 or 20,000 before. Now I have 500. A lot of them are still being suppressed. And so I may want to look at that a little bit more. But the median distortion is much less. We're now within 2% of the true answer. So I'm a little bit interested in these bins that are being suppressed as an analyst. So I can come down and I can request kind of a side-by-side view. We call it the combined view here. But I can put side-by-side the original data with the anonymized data. And it shows, for instance, for each output bin, how much distortion there is for that bin. And if, for instance, I sort the data by count, then I can see a lot of rows a lot of bins that have been suppressed, which I know because of the gray color. But I can see, for instance, there was a trip of 40 miles and $100 that was suppressed. There was a trip of 30 miles and $99 that was suppressed. And, I might decide, okay, maybe that's all right. A lot of these bins are being suppressed, but it amounts to, 0.1% of the overall data. So I'm not going to worry about that too much. And I think this data quality is good enough. So at that point, I can output the data to a CSV file. And I know I'm going a little over time, but we're almost done here. So I've output my data, and let me just quickly look at it. So this is the data that I just output. It's a CSV, so it can come up in Excel, for instance, or lots of other data visualization tools. And for instance, I can pick some slides, and I can make let's say a scatter plot from that. And then I can see that there's this correlation between trip amount, a trip distance, and how much cost. And there's some funny data points down here where you had 0 cost trips, so that's a little weird. And some funny data points up here where you had 0 distance trips that costed a lot of money, and so on. So there's some funny things, but the correlation is there, and then one can clean this up and output it, and not have to worry about whether they've anonymized it correctly or not. So that's sort of a walkthrough of how the system works. And again, what I just showed you at some point really should replace a multi multi-week or certainly even multi-month process for outputting anonymization. Of course, I'm used to this system, and it was a simple example, but I did it in, in 5 or 10 minutes time. Anyway, this is my last slide, and it's really a call to join us. We just released this software yesterday, so this is kind of a beta release of the system. We're looking for early adopters, and these early adopters, besides getting usage out of the system, can help drive requirements and features. If you want to use it to release some actual data, we would be happy to work with you to get approval from your data protection officer or your data protection authority. And yeah, if your company has data anonymity projects, please inform them. Get them to download the product from this website here, opendiffics.org. And if they like it and they're interested, they can contact us, and we can go from there. So that's it. I'm sorry for running over, but I'm done.
Paul, thank you very much. That was just an excellent presentation of the idea of anonymization in general and the techniques, but also then your tool, OpenDiffics. There is already a first question on OpenDiffic, and the question was, how robust is your tool against upcoming technology for de-anonymization? Did you think about a dynamic approach to change the anonymization techniques in the background?
I'm not quite sure what the question means. I mean,
I assume that it means, for example, if you find new technologies for anonymization, is then the software updated automatically, or do I then need to?
At the moment, no. I mean, obviously it could be. I mean, I think for me the worst danger is that somebody comes up with a new attack. So we have an approach. We have our analysis of that approach covering many different attacks and covering what we learned from the bounty programs earlier. But naturally, somebody may come up with a new attack. I mean, this is how things go. And then we have to respond to that somehow, right? We would have to update the software, design a defense for that attack, put it in the system. Hopefully there is a defense, and so on. At the moment, we don't have automatic software update to fix that, but we certainly could. But this is a process whereby we have to be in touch with our users. And if a vulnerability is found, we have to say what it is, let them know the danger. They can decide how to respond. We work on a fix and so on. So just the normal thing that any security company would have to do.
Perfect. I think we have quite a good number of questions, and we have very sophisticated questions. So, Paul, what do you think about synthetic data generalization approaches vis-a-vis data anonymization by using models such as GANs or VAEs, which reproduces the data distribution lean and an approximated distribution? For the non-technical audience, such as me, could you explain the difference, for, maybe in a general sense first, before you respond to this question?
Yeah. So synthetic data data production and also these techniques he talked about are related to machine learning, and they're the basic idea is that you, and actually my detailed knowledge of this is not what it should be, but the basic idea is you use machine learning to create models of the data, and these models are a good reflection of the statistical nature of the data itself. And then from these models, you generate synthetic data. So you generate a model from the original data, and then you generate synthetic data, which is no longer the real data from the models. And this synthetic data is a good image, supposed to be, a somewhat accurate reflection of the original real data. But since it's synthetic, the idea is now it's protected. In a way, under the hood, it's all kind of the same, right? In the end, you're still doing a form of generalization or suppressing things or adding noise or something. And how secure these synthetic data, how secure it is, depends a little bit on the model that you built, right? If the model is a bit overfitted or something, then there might be a little information about individuals leaking out. But in general, I believe in practice, this kind of synthetic data would, practically speaking, be strong enough for almost any use case from an anonymity point of view. And then it really becomes a question of whether the quality of the data that you get out matches your needs or not. I will point out that with our system, with an extra step, you could generate synthetic data if you wanted. So if, in the example I gave in the demo, I produced a histogram of trip length and trip cost. This is a very simplified example. There could be more columns, but one could take that histogram and then reproduce synthetic data from that just by looking at the count of each histogram bar and then assigning individuals to that, and produce synthetic data that way. So, in a sense, it's all kind of the same. There's no magic. You have to do a lot of the same things. You end up with data which is generally strong enough for any use case. But the question of the quality remains, and then you have to be able to work with that data to get the quality you want.
So for me, as a non-specialist, it really sounds like two different methods trying to achieve a very similar goal. And then the question is, how robust are these methodologies and how good is the result?
Yeah, it's a different approach, but at a high level, the same kinds of things happen.
Okay,
underneath.
The next question is, how did you mitigate the successful end 2019 attack demonstrated by Yves Alexandre de Montoyer? Could you again? I think again you need to explain a little bit. What was it all about?
Okay. So as I said, we were transparent about our technology. We published and we ran a bounty program. And there's a researcher, Yves, who is a researcher at in London.
Isn't it important?
It's not important.
What did he do?
He came up with an attack and demonstrated some things about the attack that worked. The frustrating thing from my point of view, by the way, he published the attack in July. In January of that year, 6 months earlier, we had found the attack ourselves and had already fixed it. But he never actually ran the attack on our system. He ran the attack on a system that he built to behave like our system. So, we could get into detail as to how the attack worked and how he fixed it, but it's not really necessary. The attack doesn't work on our current system, primarily because the mechanisms that were required for the attack are not there in the first place. But yeah, we had found that attack ourselves and we had fixed it 6 months before he published. So
okay.
It was a little bit frustrating for us to see that publication when it had already been fixed.
Okay, Paul, then another question was, how do you actually measure the amount of anonymity pseudonymization? Have you used methods other than key anonymity for the calculations? So how do you measure?
That's a very good question. That's a whole talk in and of itself. It's actually a talk I gave earlier today. So our approach is roughly the following. So again, to provide a little bit of background, sometimes people look at K anonymity and there's this value K, and the higher K is, the stronger the anonymity. So people are comfortable to have a number like this. Or differential privacy has a value epsilon, and the lower that epsilon, the stronger the anonymity. So people like to have that kind of value to work with. We take a slightly different approach, and this is primarily because we're not a formal approach per se. And I would say the reason we're not a formal approach is we're trying to get better data quality than K anonymity and differential privacy. So we take an approach where we run an attack and we have a couple of measures as to how effective that attack was. And one of the measures, it's related to precision in machine learning. It's a precision-like measure that basically tells the attacker what fraction of their they make a guess about data in the system, and it tells them what fraction of those guesses are correct or incorrect. And we roughly run so that if 50% or less are correct, then it's pretty strong. And we have a second measure, which is how often. Sometimes there are ways of getting high precision estimates, but they only happen on 1 in 10,000 or 1 in 100,000 users. And so that's our second measure. So one is how accurate the guess is that the attacker makes, and one is how frequently or on how many users they're able to make that guess. And so we run these attacks, various attacks on the system. We make these measures, and it's this set of measures that we use to show how anonymous the system is. It's a bit more complex than just a K or an epsilon, but it works for us, and I think it's a good system. But again, it would be great to work with some of you to bring this to data protection authorities and to get their buy-in to this kind of approach.
That was your last slide, this please join us and let's work together. So if I'm now totally enthusiastic about what you have just presented, so what are the next steps? So I subscribe on your website and can download the tool, or how does it work?
Yeah, you can go to the website. I showed, I don't know, I hope I didn't just kill you. I showed it before. It's opendiffics.org. You can just download the tool from there. It's very simple. So you can, and we provide some data that you can play with to give you an idea if it's going to work for you. And yes, we have our email address. You can contact us. We'd be happy to work with you. We have a newsletter. You can join it. So, and if you're really interested, we can talk about how you might get involved in the project itself. But just to get started, it's all there online, and you can log in and download the tool.
Paul, in our question and answers, we have become very technical on how your tool works and so on and so forth. Let me move to a much more general level. Try and imagine that you're bumping into a CEO of a whatever insurance company or telecommunications company, and he says, "Oh, are you the Paul Francis? You're working on anonymization. Should we do this?" And what would be your response to a CEO who has heard something about it, and what would be your arguments here? Should we engage in this endeavor? Is it important for us?
Yeah, and I would say not necessarily. And the reason is any anonymization, including ours, degrades the quality of the data. It degrades what you can do with the data. And the benefits, of course, of anonymized data is it's no longer personal, so you're free to throw it around. But the downside is that it's not as useful as it was.
So for what use cases would you say is it a good way to move forward?
So the use case that AirCloak had success with is actually inside a company. So you had a small number of people that might be, so telecommunications, for instance, or banking, you had a small group of people that had access to the raw data. You didn't want to give everybody in the company access to the raw data. You want to minimize the amount of people that can look at the original data. And yet they would often want to share statistics about that data with other business units within the company. So this was the first use case where you kind of minimize who gets to look at all the data, and yet allow them to fairly freely share that the statistics of that data internally or even externally in business reports or something. But I would like to move towards applications, for instance, in open data, government open data kinds of things, where we make it much easier for government organizations to publish data and to do it safely. I mean, there are other use cases, for instance, where there's value in the data for selling sort of the statistical output, like banking or credit cards or mobility data. It's valuable for people outside the company. So if there's a business model for selling that data externally, then a tool like ours could be used to do so safely. So there are use cases like that, but it's not a panacea for every possible use case.
Paul, then final question and a very quick response to this. So if you have now convinced me that there are some use cases in my company that I should apply anonymization, when are the instances that I should use your tool, or rather do it alone or with other tools? So when are the circumstances or the cases where your tool is really the best way to go for, rather than to do it alone?
Yeah, it's a good question. I mean, doing it alone, all right, our tool, so aspects of this question. The simple tool I showed you, it just runs on a desktop, so it only scales so well. It uploads a CSV file, so the amount of data you can deal with is pretty small. Later, we're going to do a Postgres extension that will make it much more scalable for like larger enterprise applications, but we're not there yet. So scale is possibly one reason. A second reason, though, is maybe your interest is in machine learning or something like that. And our system is just doing what's often called descriptive analytics. It's just producing whatever, pie charts or histograms or heat maps or, things like this, just looking at the data, which is good for a lot of things. But if you want to do machine learning or something on this data or something like that, then you need to work with something else.
Perfect. Paul, we need to come to an end, and there is a final question. How can it help your tool with open data, that was your argument, when you don't know the use cases of the data user? Does this not lower the worth of the information immensely? Your argument was you would like to see your tool be used for open data, but if then the quality is lowered and you don't know the use case of the final data user, does it make sense?
So we're trying to build this tool so that it satisfies many use cases in and of itself. So what I showed you can deal with, it's fairly limited. It deals with text columns and numeric columns. And we'll add to this, date time columns. But nevertheless, if this is what your data looks like in the first place, and you're satisfied with outputting things like histogram type information or heat map type information, then then it can satisfy a lot of use cases. So in the end, people just have to look at the tool and say, does this satisfy my use case or not? If yes, great. If not, they can come talk to us, and maybe we can prioritize whatever needs to be done to satisfy their use case. But the idea in general is that this is fairly general purpose and can accommodate a lot of different use cases.
Paul, just judging from all the questions, I think that you really hit a nerve. And thank you very much for your presentation and for all the frank answers. And everybody is invited to join in to support this endeavor and to further develop this approach. Paul Francis, thank you very much for your time and for this presentation.
Thank you very much. It's my pleasure.
So this brings me to the closing of this event, and I would like to remind you that the next episode will be on the 1st of December, and the topic will be Women in Tech, Inspiring Career Changes for IT, and our guest will be from the Otto Group. It is Dr. Friederike Fritsche. She is Tech Ambassador and Lead Woman in Tech, and develop her at Otto. And we are looking forward to seeing you back. And if you say, oh wow, this topic could also be of great interest to some of my colleagues or friends in other organizations, please feel free to forward this invitation. And then we are looking forward to seeing you back on the 1st of December at 4 o'clock in the afternoon. Thank you very much for your attention, and thank you very much for all your questions. Bye-bye.